Well, hopefully it all works out for her. All right, so we're finishing up the quiz. Let's turn those in. And we are going to recap. We're going to write another equation for a logistic function. Okay? Now, does anybody remember, or can you tell from your notes, what is the format of the logistic function that we're going to be writing? Y equals what? What am I shooting for? A over 1 plus BC to the x. So we are looking for a lot of different numbers, A, B, and C. So here's the given. I have an initial value of 25 fourths. I have a limit to growth of 10, and my curve contains the point 3, 50, 29. So this is the given. This is exactly the kind of given they give you in your book. In the homework problems, they give you this information and say, write the equation of the logistic function. All right. So it's been a long time since we did it. We only did one. You may not remember. Look at your notes. Can you tell? What was the first thing we did? What about that limit to growth? That's the A value. So that's where we started. We said that our limit to growth is 10. So our equation is going to look like this. Given, that's given, automatic. Okay, can you tell what we did next from your notes? Michael, where are your notes? Can you tell what we did next?
Oh, 5 fourths is plugged in. Are you asking?
Yeah. Yeah, we're all supposed to be looking at our notes.
We plugged in 5 fourths.
We plugged in 5 fourths. Well, I don't have a 5 fourths in my problem. So what was the equivalent?
It was the initial value.
Okay, so I plugged in the initial value.
25 fourths equals 10 over 1 plus BC to the x.
Okay, but not to the x. To the what? If it's the initial value, what does that mean? That means the x value is 0. We're starting at the beginning, not raising to any powers yet. We haven't done any multiplication yet. This initial value is the y-intercept. Okay, so Michael's right. We're going to put 25 fourths in for y and 0 in for x. Now, what's the beautiful thing about having a 0 in that location?
It just makes it 1.
It makes 1. So basically that's gone, and you have 25 fourths equals 10 over 1 plus b. Now, do you remember what we did next? We cross-multiplied. So 25 plus 25b equals 40. And 25b equals 15, and b equals 15 25ths or 3/5. So now I know b. So now I have y equals 10 over 1 plus 3/5 c to the x. Limit to growth gives you a, period, every time, gives you your numerator. The initial value is the value of y when x is 0. In these problems, x is almost always time, like 15 years, 18 years, 1 month, whatever. So this, if that's 0, that means at the beginning of time, the initial value. All right, where do I go from here? Take the other point, just the random point, and plug that in, and that should give me my value of c. boy, that's a mess. What do you think I should do with that? Cross multiply, absolutely, we want to cross multiply. So we're going to have 50 plus, I'm multiplying here, so 50 times 1, what's 50 times 3/5? 30 c cubed equals 290. So 30 c cubed equals 240. Oh, look at this. C cubed equals 8. So C equals 2. How beautiful is that? So our answer, we have to write an equation. Y equals 10 over 1 plus 3/5 times 2 to the x. Remember that just like with the exponential, don't be trying to multiply these together. These are two separate numbers, just like they are with your exponentials. Okay?
This is 3-1.
We're actually kind of mixing 3-1 and 3-2. By the time I'm done today, you should be able to do both 3-1 and 3-2. They kind of overlap a little bit. Okay? Everybody got it? So you're going to practice a couple of those in your homework. Probably there'll be one on your test. That would be my guess. Now, I'd like you to look on page 297, page 297 of your book. Everybody's on 297. Okay, so 297. Katie, I need to talk to you after class, okay? You missed some stuff. All right? Everybody, we're looking at number 31, problem 31. So now we're doing a little word problem, backing up and reviewing a little bit about what we talked about the other day when we did this. Population of Smallville in the year 1890 was 6,250. Assume the population increased at a rate of 2.75% per year. Now, that is enough information for you to write an exponential function. You have been given enough information. Forget the A and the B, the questions. Forget those for a minute. Write me an equation that talks about an initial population of 6,250 and an increase of 2.75% per year. What would that equation look like? Y equals what? 6,250, because we talked the other day, kids, what is A? The initial value. In an exponential, this is in the initial value. Now I'm going to multiply that by something to a power. And the something has to reflect the growth in the problem. So what will that be? 1 point, I can't remember, what was the percentage? 2.75. So it would be 1.0275. Remember, this number shows your rate of increase or decrease, right? But it's not a single percentage. It's 1 plus the increase or 1 minus the decrease. So if we had a 10% decrease, we would multiply by 0.9. Remember that? We talked about that the other day. So this is the equation we are going to use to do problem 31. Does that equation, everybody get where those numbers came from? Why we put them where we put them? All right, let's look at question A. Estimate the population in 1915. what am I going to plug in for X? Not 1915. Be careful. Because what did this represent? That was the population in 1890. So 1890 is like the 0 point. So what would 1915 be? 25. So the answer to problem A would be 6250 times 1.0275 to the 25th. Does everybody understand why it's 25? The initial population was in 1890. So how many years past 1890 is 1915? 25. Okay? Now, this is a population. When you type that in on your calculator, you're going to get some point, round it off to the nearest person. This is a population, so we don't want decimal people. Round up or round down, whatever's the closest. Okay? According to my book, which has the answer, it should be 12,315.
Yeah.
Is that what you got? All right, there's a second part to that question. Jade, raise your hand up.
I just had a question on what you said earlier. So I wasn't here when you guys talked about the one. You said there's
What should Jade be doing if she weren't here?
watch the video.
There you go. Haven't done that yet. Well, you watch that and I'll take care of your questions.
Okay.
Now, there's a second part to that question. What's the second part?
1940.
1940. Now, you're going to do the second part of the question exactly like you did the first part, except this isn't going to be a 25. What's it going to be? 50. And why is it 50? Because it's 50 years after the problem began. The problem began in 1890. So by the time you get to 1940, that would be 50 years after you started. So according to my book, that should be 24,265. Everybody okay with that? 24,000 and some. 265.
That's for the 50.
For the 50 one. All right. Change your hand up.
No, sorry.
It's okay. You can adjust your ponytail. Now, letter B. This is where things get interesting. Letter B says, predict. Now, we're still using this equation right here. This is our equation. Predict when the population reached 20,000. Now, this is your equation that you're using. What are you going to do with the 20,000? Where does it go? It goes in for Y. So we have 20,000. Oh, is it 50,000?
No, it's 20,000.
I'm doing problem B that says predict predict when the population's 20,000.
Oh wait, 31 and 32 are the exact same question. Oh wait, no.
Oh, I'm doing 31. Yes, it is 50,000. Thank you. All right. So let me back up. I'm doing 31, not 32, although they'll be done the same way. But let's do 31 since that's what I said. Predict when the population reached 50,000. So does everybody understand that the 50,000 now goes in for Y? And I have this equation to solve. Now, step 1. I want you to divide by 6250. That comes out to be even, so it's 8. So we divided by 6250. Brenton said we got 8. Now, if the equation looked like this, 8 equals 2 to the x, then it would be very easy, wouldn't it? Because everybody knows 2 to the third is 8. This, everybody doesn't know. Do you remember how you solve for an exponent when you can't get a common base? These do not have the same base. It's not like 8 and 2. Ah, we take the logarithm of both sides. Now, some of you said ln. I don't care which you take. You can log or you can ln. It will make absolutely no difference in the answer. The only thing is you have to press the right buttons on your calculator. I'm going to go ahead and log both sides. Now, why do I do that? There's something special that happens when you take the logarithm of something to a power. Do you remember what happens? This is one of your properties of logarithms. When you take the logarithm of something to a power, the power comes out front as a coefficient. So we have the log of 8 equal to x log 1.0275. When you take the logarithm of something to a power, you may pull the power off and make it a coefficient. It's one of the properties of logarithms, one of the beautiful things about logarithms. Now, what's so happy about that? What's so good about that? Now I can divide. So x equals the log of 8 divided by the log of 1.0275. Now, when you type that into your calculator, as soon as you press log, it's going to put a parentheses in there, and you're going to type 8. Then you're going to want to close that parentheses before you hit divided by. So it's going to be the log of 8 divided by the log of 1.0275, and that'll tell you how many years it's going to take.
76.65.
So 76. 77 years?
Well, if you round it.
If we round it off, let's round it off. We'll just say 77 years. Now, be careful. The question said, predict when the population reached that. Now, that 77 means 77 years after we started. So when did we start? 1890. So the answer to the question would be 1967, because we waited 77 years after the initial value. Okay, now let's try 32. It's the same problem. We've already noticed that. We just have different numbers. So the first thing I want you to do with problem 32 is write down the equation you're going to use. Michael, quit watching the clock. This is good stuff. And when this bell rings, you just have to go to some boarding class. This is more fun. All right, so here we go. The population of River City was 4,200. It increased at a rate of 2.25% per year. Don't even answer a question. Write the equation. Y equals what? 4,200 times 1.0, was it 2.25? 2.25 to the x. We're on problem 32. The initial value, read it. The initial value is 4,200. And we're increasing at a rate of 2.25%. There's my equation. Question A. Estimate the population in 1930. Put 20 in for X. Why would we put 20 in for X? Because we started in 1910. 1930 would be 20 years after that. So you're going to put 20 in for X. You're going to type that into your calculator and round it off to the nearest person. Brenton, you got it?
Yeah.
What is it?
6,500.
6,554. Is Brenton right? Okay. Next question. I'm not going to do the second part of that because it's the same thing. The next question. Predict when the population reached 20,000. This is different. The 20,000 goes here, right? Y is the population. X is the years. So what's step one? Do you remember from the one we did before this? Divide. Please don't be LOGing, LNing, anything like that until you get rid of this number. This number's got to be divided. So 20,000 divided by 4,200. It's not going to go in as nicely, is it? As the last one. But that's life in the fast lane. If I don't want to round it off, I'll just say 121st. Alright, so let's talk about that. On my calculator, I took 20,000 and divided it by 4,200, and I got some crazy decimal. I would prefer not to round it off. So I hit math, enter, enter. I think I hit it twice. Math frac. And that gives me the fraction equivalent of that decimal. So if you hit, you round it off. So if you hit math frac, it will give you the rounded off form, or I mean the decimal form, so you don't have to round off. Now what am I going to do? I'm going to log both sides. And just to show you it makes no difference, I'm going to ln this one. It does not make a single bit of difference. Personally, I don't ln on my own unless there's an E in the problem. And we'll talk about why that is later. But it doesn't hurt a thing. You can ln or log, makes absolutely no difference. However, no matter which one you used, what are you going to do now that you've ln'd it? Now that you've logged it, you're going to do what? Pull the exponent off. So we have ln 121st equals x ln 1.0225. Now I'm going to divide both sides by the ln 1.0225. Now, if you logged, that's fine. You're just using your log button. I'm using my ln button. And what did you come up with? I got about 70 years. About 70 years. So let's make sure we answer the question. It was predict when the population reached that number. So it's 70 years after we started. So it would be about 1980. Everybody got that okay? Good. Very, very good. All right. I've got one more in here. Number 40. Number 40. Radiocarbon dating. Okay. The amount seen green. Okay, so this time they gave me an equation. You do not have to write your own this time. They gave it to you. Oh, shoot, my eyes aren't good. How many zeros? 1, 2, 3, and 2 and 6. There's 3 zeros after the decimal point, right? So that's the equation I'm going to be using. Now it says, the problem says, estimate the half-life of carbon-14. What does half-life mean? How long it takes. So we're looking for a time. How long is it going to take for what to happen? To have half of what you started with? Okay, let's look at the equation. How much did I start with? 20. So half-life would mean I had 10 left. So I'm going to put a 10 in right here. And I'm going to find the t that would give that to me. Divide by 20. Very good, Brenton. We always got to get rid of that number. No matter what, I got to get rid of that number.
Now, is this where you would put
I would. Now, any problem you can do with LNG or LN. LN's going to be easier, and I'll show you why. At this point, I'm going to do what I did over here. I'm going to LN both sides. So I have LN 0.5 equal LN E to the negative all this. And then why did I do that? Why do I take the logarithm of both sides? So that the exponent can come out in front, right? So here we go. Ln 0.5 equals negative 0.0001216 T ln E. Now, before you type anything else in on your calculator, I want you to figure out what LNE is. Okay, so do you know how to do that? Press LN. And then to get E on your calculator, you have to second LN. Did that pull E up?
Yep.
And we want it to the first power. What'd you get? 1. LNE is 1. LNE is 1. Always. So basically, this side of the equation is just the exponent. So what are you going to divide by? You're going to take ln 0.5 and divide by what? Just that decimal, right. Negative 0.0001216. I got about 5,700 years, did you?
Yeah.
Put in the one exponent for that. Like you put ln and like second.
Yeah, and then you have to put in 1. Now, from now on, we're not going to do that though, Katie, because I told you that's always going to be 1. So anytime we have an LNE, we're just forgetting it because it's just 1. Brooke? We're dealing with half-life, and the initial value is 20, so half-life would be 10. If the initial value had been 18, I would go to 9. All right? We got it?
Yeah.
Okay, so we got a good introduction to logarithms. You should now be able to do on your homework sheet, you should be able to do 3-1 and 3-2. 3-1 and 3-2 should be done now. Okay? All right. You're free to escape. I know you can't wait.